Okay, so I've given you some time to think about this lily pond situation. Now it's time to reveal the answers. But before we get into the answer, because I know that's what everybody wants to know, let's talk about what exponential growth is by first looking at the heck are exponents. So you might already know, and you might not, but you've probably seen something like this. This is 5 to the third power. It's 5 with a little 3 floating next to it. Now that little 3 is an exponent. And it means something. The big number 5 is referred to as the base. So this is 5 to the third power, aka 5 cubed. Now you might already know that if a 2 is there, that's 5 squared. So 2 and 3 have a shorter version of saying it, but it's also to the power of 2 or to the power of 3, to the third power, to the second power. These are exponents, and this is what they mean. 5 to the third power means 5 times 5 times 5. It's the base multiplied times itself 3 times. Now 5 times 5 is 25, and 25 times 5 is 125. So 5 to the third power, 5 cubed, is 125. So how does this apply to the lilies? Well, the lilies were 2 as the base. So 2 squared is 2 times 2, which is 4. And then 2 cubed is 2 times 2 times 2, which is 8. And so on. Now, this is kind of what it looks like in terms of exponential form, right? So we have 2 squared is 2 times 2. You can see that. And 2 to the third power is 2 times 2 times 2, which is 8. Now, some things that you might not realize is 2 to the first power. Now, the first power is an exponent that means just the base, just 2. And there's even a 0 power, which means 1. And that's the first lily. So anything to the 0 power is 1. It's the first lily. It's the first appearance of the pad, so it's 1. And then what happens after that changes based on the base. So our base was 2, so it went from 1 to 2, and then from 2 to 4, and then from 4 to 8, and then from 8 to 16, right? And you can see what it looks like graphed. These are exponents. Now, I'm not sure that you did the math for the lily pads. It's kind of crazy. I hope you didn't. It starts off relatively simple. You're doubling, but as you keep going, it just gets astronomically big. I mean, it just gets enormous. And there's no point in doing it. You don't even need to do that to figure out what the answer to the question is. So let's go back and look at it again. Remember, our lily pad starts out with 1, and then it goes to 2, and then it goes to 4. And they said by the 60th day, the entire pond is covered. So what day is half the pond covered? And the answer is day 59. It's actually the day before. And it makes sense when you think about it because remember, it's always doubling. So if it goes from half the pond on one day, then double that, it's 100% of the pond on day 60. So when will the pond be half covered? The day before that it's all covered. Now, if you think about it in terms of going backwards, on day 60, 100% of the pond is covered. And we needed to know okay, well, let me go backwards. What's day 59? Remember, it's always doubling each day. So going backwards, it would be halving each day. So at 100% of the pond on day 60, if I half that, that means that 50% of the pond is covered on day 59. Now, this type of backwards thinking will help you answer the second question. Remember, the second question is that if on day 60 the entire pond is covered, which will be the first day where at least 1% is covered? So let's go back to that backwards thinking. We already know that the percent halves each day if we go backwards. So on day 60 it's 100, on day 59 it's 50. So let's keep halving the percentage. On day 58 it's 25. On day 57 it's 12.5%. Then it's 6.25%. Then it's 3.125%. Then it's 1.5625%. We're getting closer. and then it's 0.78125%. So the first day that crossed over 1% is day 54. If you got that, I'm impressed. But what does this mean? It means a lot. And when we talk about COVID-19, like, you'll kind of understand why this all connects and how the math is involved here. So in our lily pond, 53 of the 60 days, we had 60 days, 53 of those days, almost all of those days, were under 1%. By day 54, it had finally crossed over 1%. So now we're at 1.5%, and there's only 6 days left. And in 6 days, it goes from 1.5% to 100% of the pond is full. That's exponential growth. We had 53 days of nothing. And then we had 6 days where it went from 1% to 100%. It's like, boom. That's exponential growth. This is a graph of the first 20 days of the pond. Just the first 20. Take a look at it. It's exponential growth. 2 is the base. This is a graph of the COVID-19 cases in Pennsylvania as of March 23rd. Look similar? Now, I'm not trying to freak you out, because there's a reason that we're communicating through virtual reality here. Because we're trying to stop. We're trying to slow this down. And actually, if you notice the difference between the first arc I showed you here and the second arc I showed you, is that it's not as steep, because the base of COVID-19 doesn't double every day. It seems to be, based on various things I've read, about a 1.4 each day. So that's times 1.4 each day, which is exponentially growing. It's growing and growing and growing. And here's graphs of all the different countries that have had cases. And you'll notice they're all a little different, but they're overall trending to be exponentially growing. Now, if you look, China, where it actually started, is the lowest. It's actually low. And South Korea and Japan are even lower than that. They're not on this graph. I just found this somewhere. But that's because they're social distancing. And this is why we're doing this. Okay? Social distancing, the reason that we're staying home, the reason we're telling people to stay home is for this reason. We can control the arc of the exponential growth based on how fast people are being infected. So you might have seen this if you watch the news, this idea that there's 2 potential growth trajectories. We can either have an extreme exponential growth. Now, it can't grow forever, right? Like, there's only so many people that can get the virus, so it can't grow forever. But it'll just grow until everybody's got it, and then everybody will get better and it'll come down. The problem with that is that even though in most cases people don't need a lot of health care for this, they say most people that get it, they have some mild symptoms, they have a bad flu, and then a couple days later they're fine, right? Which is great. It's great news. And kids seem to be even better as far as how they deal with the virus. The problem is that a small percentage of people do need medical attention. And what happens is, when you have an exponential growth, like we showed with the lily ponds, we had a 6-day span that went from 1% of people had it to everybody had it. So if we did that with COVID-19, we would basically have a 1 to 2 week period where it would go from, 1% of the population has this virus to everybody has this virus. Which is fine, except for the fact that some people do need medical attention. Not everybody, but some people do. And there's just not enough hospital beds and not enough doctors and respirators to handle the surge. So the reason that we're having social distancing, the reason that we're doing this even now with online schooling, is so we can slow the growth rate down. And that way, if somebody gets the virus, and most cases they're fine, but if they have to go to the hospital, there's a bed. And if they need a respirator, there's a respirator. That's why we're trying to slow down the virus. And the only way we can do it is by social distancing, is by staying away. So I'm not trying to scare you. I'm trying to tell you this is the math in real life. This is happening. And this is the reason that we're doing what we're doing. So a couple of tidbits before I let you go. Social distancing reminders. 1, you got to frequently wash your hands with soap and water for at least 20 seconds. I'm talking scrub in between the fingers. Turn them, thumb, squiggly. Like get them wet, get them clean. And do that frequently because that will clear the virus off of your hands. And I've been touching my face this entire video. Avoid large gatherings of people. You know, that's the hardest part. It's so hard to just not be with people, but we have to. It's not going to last forever. It's just long enough to slow the curve down so we can get through this and we'll be on the other side. And then the last one, if you try to stay inside. Try to just limit who you see in person. That's what FaceTime is for. But if you do go outside, try to stay at least 6 feet away from other people because that will lower your chances of spreading the virus, right? And it's not about you getting sick. It's about the virus spreading at a rate so quickly because if you get sick, then someone else you know gets sick, and then someone else you know gets sick, and it just keeps going. So that's why we're doing social distancing. That's exponential growth. It's a math in the real world. So that's all I got for you today. Hope you enjoyed it. See you next time.